this is problem 6 from section 1.8. From the intermediate value theorem, is it guaranteed that there is a root of the given equation in the given interval? Given interval is 0 to 1. The equation is cosine x equals x. All right, let's look at this. Cosine x equals x. You want to find an x between 0 and 1. Question is, can you find an x between 0 and 1? We'll get the x to one side. That means cosine x minus x is 0. Let fx be the function cosine x minus x. Note, f is continuous because cosine is continuous and x is continuous on all of real number line. So the difference is continuous function. In particular, because it is continuous on the entire number line, it is continuous on the closed interval 0 to 1. What happens to f at 0? Plug in 0. Cosine 0 is 1, x is 0, 1 minus 0 is 1, which is a positive number. On the other hand, if I plug in 1, I get cosine 1 minus 1. You can check using your calculator or even otherwise logically. Look, the maximum cosine can go is 1. When does cosine become 1? Cosine become 1 at 0, pi, 2 pi, 3 pi, so on. 1 is not 0, pi, 2 pi, 3 pi, so on. So cosine 1 is going to be smaller than 1. Something smaller than 1 minus 1 is going to be negative. In other words, f at 0 is positive, f at 1 is negative. So between 0 and 1, there will be a point when f is equal 0. So by the intermediate value theorem, for every number between this point and this point, you will have a c such that fc is n could be 0. So we are guaranteed a root. So it is a yes. Next problem. The table below gives the value of continuous function f at each x value. Using the intermediate value theorem and the information on the table, determine the smallest interval, one in which the function must have a root. Look, function value is positive, 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 negative, 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 negative. So from positive to negative, there is going to be a 0 between the two. In other words, in this interval, negative 1 to 0, you are bound to find a root or a 0. All right? Oops, I did not submit. Submit. Correct. Next. Now this is a longish problem. It's kind of theory is detailed. You might find it hard to follow, but try following the rules. Rules of the game are given here. You are given fx, x squared minus 42 in this particular case. You are given a starting column, row 6, 7, 0.5, 6.5. How did these numbers arrive? A is 6, B is 7, that's their choice because they plugged it in my function f. One gives me a negative, the other gives me a positive. They plugged it in and checked. Okay. What is h? Take the distance between the two and divide that by 2. Distance between these two is 1, divided by 2 is 1/2 or 0.5. What is m? M stands for midpoint. Midpoint is the distance between these two. So what they are saying is, now apply f on m, that is, plug this in your function. If you get positive, then that goes in the B column. If it is negative, then that goes in the A column. So you keep doing that. You say you put this here. If this is negative, if this is positive, this goes in the B column. If it is negative, it goes in the A column. But regardless, once you have that, again you can find half of the distance between these two numbers and find the midpoint of these two numbers and then continue the procedure. So notice, if I put this in the B column, then A column remains unchanged. If I put something in the A column, then B column remains unchanged. So how do I determine where my midpoint goes, A column or B column? Again, I repeat, if the value of function at the midpoint is greater 0, then it goes in the B column. If it is less 0, then it goes in the A column. All right, so that's all the procedure is. Okay. So A1 is 6, B1 is 7. You plug it in, check f is this function. Plug for A1, it's negative. Plug for B1, it's positive. Find the midpoint between A column and B column. Find half the distance between A column and B column. By half the distance, that's why I have absolute value. I don't want distance to be negative. Now, use your midpoint. Evaluate it at your function f. Aha, it is positive. So the B column gets midpoint, A column remains unchanged. Now again find the half the distance and find the new midpoint of these 2 points. All right, now plug this in your function. It is negative. Aha, that means this replaces the A column. So B column is unchanged. Now find half their distance using absolute value over 2 and then find the midpoint, which is average of these 2. Now find f at that value. It's still negative, so it goes there. Find half the distance. By the way, when some midpoint goes to one of the columns, the other column remains unchanged, okay? Find the midpoint. Find its value. Turns out it is negative 2, so that goes here. This remains unchanged. The midpoint of these 2 and the distance between these 2. So this, after 5 iterations, the value you get here is an approximation to the root, and this is the amount of error, okay, that you have. Okay, next problem. Carry out 3 steps of the bisection method. Your function is 4 to the x minus x to the 4. Show that fx has a 0 in 1, 2. Well, what happens at 1? Positive. What happens at 2? Negative. So there is a 0 between these 2. Now, similarly, check for this interval, check for this interval. See which at the end points you need different signs. Okay, I have checked here and here. I get 1 positive, 1 negative. So that's the interval I put in. Likewise, check for these 3, 4 intervals. Make sure the endpoints you get different signs. I checked the very first interval worked for me, so I'll complete this here. Okay. So my next video will handle the last problem of this section.